Hello everyone, welcome back to my YouTube channel. I am Manashri. I am currently pursuing my first sem MBA in Sri Venkateshwara College of Engineering, Bengaluru, affiliated to VTU, Belgavi. So in this video, we will be talking about statistics for manager. It is one of the subjects for us, and the topic today we will be discussing is the central limit theorem. So firstly, what is sampling distribution and what is samples? So when we have collected the various data from various individuals, we get a sample, and in that sample, suppose we have 100 samples, we will be taking will be grouping each of them based on their mean. Will be taking the mode for their heights or weights, etc., when we have collected the data from the various people, and this sampling distribution will be able to predict their behavior of statistics in the long run. So that will be able to predict the behavior, what can it be in the future, and any changes in the variables or in the heights or weights what we have taken. So in this topic we will also be learning about the sampling distribution in an X bar. So in this what happened, as we said, when we have taken 100 people as our sample, we will be grouping each 20 of them or 10 of them, and we will be calculating their mean. Suppose we are taking 10 members mean and we have got some 25%, 25 and for next till the 100 persons we will be taking all the means, and the means what we have collected we will be taking in the graphs like this as shown in the picture. The graph will be something like this, and the average mean will almost be similar. As you can see in this data, here it is for the first 10 people it is 26.42, for the next 24.28, and for the next it is 25.22. And in this we have to note one thing is that the sampling which we have distributed will be normal. We will be calling it as a normal sampling distribution. When we have taken the sampling and we have calculated the mean and we will be taking the graph, so this will be termed as normal sampling distribution. And the next one is central limit theorem. So in this central limit theorem we have one formula, that is X bar that mean is approximately equal to n summer of mean comma standard deviation, that is sigma divided by square root of n. This will be the central limit theorem formula, and in this, as you can see in the slide, and n represents the size, and nu which is called like this is called this is the mean, and in finite, and this sigma is called as the standard deviation. And when the when the size is large, the sampling distribution of the sample X bar. So whenever the size is more, we will be taking this as the formula. The next one is no matter, as we talked that time, no matter the shape of the population, the distribution X bar tends towards normality. So as I've said, the graph will go upward and downward. Like first it will go up and then it will be falling down. So this is called as normality, normal sampling distribution. And the next we have we will be discussing how this graph will be changing when we will be taking different number of size of the people. So in the activity we have taken nu, that is mean equals 1 and the standard deviation is 1. So the graph is like this. So it is just coming downward. So we have taken only 1, and this is the result of, like, it is like this. So, and this is not normal. Normality means the graph should go up and the graph should come down. In the next slide we have taken multiple this one. So in this we have taken first x equals n equals 1. So and in the previous slide what we discussed, the same will be resulting in the picture A. So this will be like 1 person, and the standard deviation will also be 1 and mean will also be 1. And in the second one we have taken n equals 10. So when we are increasing the number of the size of the population, what is happening? The graph is slightly moving upward and coming down. So this is what happens when, and this is showing the normality. So when the size of the population is more and increasing, there will be a slight normality and the graph tends to go upward and downward. And in the next figure we have taken n equals 20, that is the size of the population is 20, and the graph is still more increasing. We can see that. And in the next this one we will be taking n equals 70, and there will be the graph has stretched more upward and it has the cone shaped and it is falling down, it is moving the downward direction. So this is called as normality. So when there is only one mean, and the mean is 1 and the standard deviation sigma is 1, the graph will not show any normality and the graph will be just like this. And when we increase the size of the population n equals 10, 20, 70, the graph will be moving upward, moving upward, moving upward. So when we include more number of persons, when we take n equals 100, n equals 200, the graph will be increasing as we increase the number of persons in the sample of the size. And yes, this is all about the central limit theorem. And next is one more activity is being given, how to calculate about the example, and this can be shown in this way. Yes. So here x is not normal, so here whatever the variables we are taking, that x is not normal, and sampling distribution of x bar based on n equals to 70 and nu x minus bar equals to 1, and standard deviation is 1 upon square root of 70. As we discussed in the last slide, the formula is being used when there is not. So here the n is 70 and there are more sample size, and we are taking more number of persons, so we will be using the formula which we had discussed lately. And the formula is 1 and here the nu is 1 and the standard deviation is 1 divided by square root of 70. As we discussed in the last this one, we had nu that is mean average, and that is mean, and standard deviation divided by square root of n. Here the square root of 70, that is n, and sigma is 1, and also mean x minus bar is 1. So how will, and the answer will be 0.02, that is n 1 comma 0.12. So it will be somewhere nearly 0 to minus 1. So as we have seen in the figure, it's somewhere there. And we can see this prediction state PR bracket x bar grade lesser than 0.83, and when we standardize it, it will be like z equals 0.83 minus 1 divided by the answer what we got 0.12, will be getting minus 1.42. That is what shown in the figure. That is in the graph we will have 0, right side will be positive figures and the left side will be the negative figures, and as we have got the negative minus 1.42, will be taking somewhere nearly to 0 to 2, will be taking minus 1.42, and sketch is right how this one, and PRZ lesser than minus 1.42, that will be equal to 0.0778. Yes, this is all about this central limit theorem, sampling distributions. Thank you for watching till the end of the video. Please do like, share and subscribe my YouTube channel. Thank you. Until the next video, please take care. Bye bye.